Okay, so hi everybody. I'm going to talk about the title of my talk is Hexagonal Architecture Demystified. So why this word demystified in the title? Why should it be kind of demystified? Well, for me, for a long time, hexagonal architecture was kind of this mystical thing because whenever I try to learn something about it, and there's no shortage of articles, blog posts, videos, tutorials, conferences, people speak about it. So there's a lot of resources, but whenever I try to read something about it, I would get overwhelmed pretty fast because all these articles, they often they would start talking about things like DDD, TDD, BDD, CQS, CQRS, ES, commands, command bus, layers. So yeah, it was just too much for me to take. And another problem is all these kind of articles, they often kind of offer a slightly different view of what hexagonal architecture is. So for me, for a long time, I was never quite sure what hexagonal architecture is. It was kind of mystical for me. So my goal for today is to kind of do for you what I did for myself, and that is to demystify it, or maybe even the word distill would maybe be a good choice of word for the title, to distill this kind of clutter around the hexagonal architecture, to kind of see what it is, like what the original idea of hexagonal architecture is, and then we can also see how we can kind of expand it and combine it with all these other architectural approaches that people often tend to do. So before I start, just a little bit about me. My name is Zvonimir. I come from Croatia, but I've been living in Berlin for almost 2 years now. This is my Twitter handle if you wish to follow me on Twitter. And yeah, I work at a company called Maybe Love, which is a Belgian company, but it's a remote first company. So yeah, they don't really care where I live as long as I commit my code often and my tests are passing. So hexagonal architecture. In 2005, Alistair Cockburn published an article called Hexagonal Architecture, and then he later revisited it, and he stated that the name ports and adapters would be actually a better name for this architecture. He said he believes it's a better description of the intent behind this architecture, but it seems to me like the name hexagonal kind of, people use it more often. I guess it's just a more cool name. But yeah, it is the same thing, those two terms. So Alistair starts his article by saying it is a response to the discussion on the traditional layered architecture. So this is how we're going to talk. We're going to start our talk by looking at layered architecture first. So layered architecture states that in order for us to better to help ourselves with comprehending and dealing with software systems, the complexity of our software systems, we should divide them into distinct layers. And the difference between layers is in the level of abstraction where these layers are going to reside. There is no limits to the number of layers, and usually if you look at, depending on the authors you're reading, usually there's like 3 to 4 layers, and here I'm going to use a 4-layered approach as it was explained in the Blue DDD book by Eric Evans. So on the top of your stack of layers, you have your user interface layer. So this is the layer where users talk to your application. This is kind of like the entry point to your application. And also this is the layer where you show some data back to the user. You communicate with the user. Below this layer, you have your application layer, which orchestrates some domain objects in your domain layer to perform some action required by the end user. And the domain layer, it contains your domain objects, your business logic. This is where it resides. And then at the bottom of this layer stack, you have your infrastructure layer. Infrastructure layer is there to give technical capabilities to support the upper layers. So it's usually it's about persisting and messaging, right? Now, the way the communication between these layers goes is it can only go downwards. So layers can only talk to layers below them. And here you can have 2 approaches. One is the strict approach where a layer can only talk to the layer that is directly below it in the stack. And then there is like a more relaxed approach where a layer can talk to all the layers that are below it in the stack. So in this case, the UI layer could directly talk to the infrastructure layer instead of going through like all these other layers, so you don't have to have these kind of proxy calls between layers. Now, another way to look at these layers, the way that we traditionally tend to think about them, is to say that the user interface layer, this is the front end of your application. The infrastructure layer, this is the backend, And then this middle part, I chose to call the core, but you can also call it maybe the heart of your software if you wish to be more poetic. Now, then came Alistair in 2005, and he proposed a different look at the system. So in Alistair's eyes, in his view, there is only two distinct parts to a system. There is the inside world, and then there is the outside world. The inside world, this is your core, this is your application. And everything else is the outside world. So in this view, the database and the web client are no longer backend and frontend, they're simply outside. Now, as we know, the outside world, in this case, our database and our web client, they probably don't talk the same language as our core, right? We're PHP developers, so our core talks PHP, while our web client talks HTTP, and our database probably some flavor of SQL. So in order for them to communicate, to talk to each other, we need this kind of transformer wrapper, transformer layer, or better call it a wrapper, another hexagon that is wrapping our core hexagon. And in this hexagon, what's going to happen is we are going to translate data from the format that the outside world can understand to the format that the inside world can understand. So in this case, we need to transform some HTTP requests into some PHP data structure, so our core can understand, and also vice versa. If our core needs to talk to the outside world, we need to transform these PHP data structures, probably some PHP objects, right, to something that our outside world can understand. In this case, the web client can understand HTTP responses. And the same goes with our database. We need to somehow translate data between these MySQL relational data and our PHP data structures, probably objects. And this transformer wrapper, this is where your adapters are going to live. So this is where ports and adapters come into play in this picture. So how does this work? How do these adapters work? Let's say in your core you have a certain use case, maybe a registered user action. It can be as simple as some kind of a service class that accepts some kind of input, right? So your use case, and I'm using the word use case here to be a bit more abstract, but technically it can be just a service class, right? In reality. And this use case, it defines kind of like an interface, right? It says, if you want to register a user, you need to pass me this data. So this is like the interface, this is the contract for talking to this use case. And in the context of an adapters architecture, this is the port. So your core is defining a port of how you can talk to it. Now, as we already mentioned, our web client cannot directly access this port because our web client talks HTTP. And our interface for our use case, that's PHP, right? So what we now need is an adapter class. And we have all written this kind of adapters, a controller class, right? So what the controller class does is it takes the HTTP request, transforms it into some PHP data structure, again, probably object, and passes that data now in this PHP data structure, passes it to our use case. And vice versa, if our use case needs to return some data, the controller class can also transform it to HTTP response. So now suppose that we need to support another way of talking to our application, another way of kind of plugging into our use case, maybe a CLI command, right? Maybe we want our developers to be able to SSH into the server and manually, like via the CLI interface, register users, or maybe our clients are kind of hacky and they also want to have like a CLI command to do these kind of actions. So again, we need an adapter class, so we write another adapter. Now we write a console command adapter, which will take data from a CLI input and again transform it to the same data structure and pass it to our use case. Now there is an interesting thing here to note. That is, when we needed to add this new way of talking to our use case, talking to our core, we didn't have to touch the code in our core. We only needed to write new code. We only needed to write a new implementation, new adapter, new concrete adapter. So you see, our core is kind of blissfully ignorant of all the different ways of talking, all the different methods of talking to the core we are going to support. So in future, if we are going to maybe support, maybe we are going to have some kind of RabbitMQ, then we can implement a RabbitMQ listener, an adapter that will take data from the RabbitMQ messages, transform them to PHP objects, and pass them to our use case. So you see, our core, our use case only cares about interfaces. It only cares about the port. And it says, as long as you can plug something that obeys this port, something that can talk to this port. I don't care where this data comes from. So this kind of architecture has this kind of, as Vague Vernon called it, potential for timelessness, right? Because you don't care in the future. There can be many other ways of talking to your application. Your core only cares about the ports. So now you see why Alistair chose when he revisited the article, chose the name ports and adapters to describe this architecture. So in this view, we can say that our system we can look at the system as kind of our core that is surrounded with interfaces to the outside world. And the reason why Alistair chose to call it hexagonal, why he chose to draw a hexagon, is actually quite simple, because it was easier to draw than a pentagon. And yeah, I'm not kidding, he really stated it. But also with this, I mean, you would get the same analogy with the pentagon, but hexagon is easier to draw. But you also get this analogy, nice visual analogy, where you can say that one edge of a hexagon represents one way of talking, one reason for talking to your application. Now, as I already mentioned, in this view of architecture, there's only the inside world and the outside world. So it's we have like this very symmetrical image where the database and the web client are no longer back and the front end, they are simply outside. So it's a very symmetrical image. But in the same time, it is also a bit of an asymmetrical image. So what I mean by this is that we can still kind of divide our ports into two distinct groups, ports and adapters. And the way we are going to divide them is based on the way they communicate with the core. So on the left side of this image, and it doesn't have to be on the left side, I just chose to draw it like this. On the left side of this image, we have our primary ports, or the driving ports. And they are called the driving ports because they are the ones who are initiating the communication with the core. So they are kind of driving the behavior of our application. Usually our web client will say to our core, hey, do something for me, or give me some data, show something to me, right? It has this kind of active role in communicating with our core. While on the other hand, the driven ports, or the secondary ports, or let's call it kind of passive ports, when they communicate with the core, it is the core that initiates communication with them. So the core will tell the database, hey, give me some data, or hey, persist some data for me. So they have this kind of more passive role in this communication. So that's why they call the driven or secondary ports. So this is it. This is ports and adapters architecture. This is hexagonal architecture. Alistair didn't mention any kind of, he gave no instructions on how you should actually structure your code inside the core. He didn't say that you should use layers, and he also didn't say that you shouldn't use layers. So what about layers, right? Because a lot of people usually use layers combined with hexagonal architecture, and a lot of people will say when you say hexagonal architecture, oh yeah, layers, and they will start talking about layers right away. So yeah, you can combine hexagonal architecture with layers, but there is a slight subtle difference, or maybe not so subtle, between what you're gonna have now with hexagonal architecture and layers, and that's traditional layered architecture. So again, we have our domain layer. It's in our core, right? Then we have this application layer that is kind of wrapping our main layer. And then the infrastructure and the user interface layer, they both live in this kind of transformer wrapper, as we chose to call it. So as you see, the difference between this and traditional layered architecture is that in traditional layered architecture, we had like a stack of layers. So layers were stacked one upon each other. While here the layers are kind of like wrapping each other. So it's more like peeling an onion, right? Like an onion. And actually there is this thing called an onion architecture. And this is really similar to that. This is kind of more a combination of onion architecture and hexagonal architecture. And this difference also means that when we talk about that communication between layers, as you remember, in traditional layered architecture, the communication would go downwards, while here it goes inwards, right? Because layers are wrapping each other. So communication goes from the outside to the inside towards our core. And this rule for about communication, where it only goes inwards, this applies to hexagonal architecture, even if you are not combining layers with it. Okay, so now that we know what hexagonal architecture is, let's take a look at one example of how we can actually implement it in PHP. This is how I kind of usually go about it, and also it's a combination of what I saw other people do it in workshops and some tutorials. So we're going to take a look at the driving side first. So here I have a simple, let's say it's cooking app. So we have our recipes and we have some users. If you're into DDD, as you see, I kind of have two bounded contexts here. If you don't know what that means, think of it like this. Everything related to a recipe will be in the recipe folder. Everything related to a user will be in the user folder. So it's kind of like two subparts of your application, two modules, distinct modules in your application. And I'm going to have one hexagon per module, one hexagon per bounded context here. I didn't choose to use layering, but I did choose to put my infrastructure and my UI in different folders. So I did make this distinction between primary ports and secondary ports, or driving ports and driven ports. And then I have my core folder. So one way of talking to my application is going to be via HTTP. So I have this create controller to create a recipe. And in it, all that my controller does is it takes some HTTP data from HTTP request. This is kind of Symfony-like code. And all it needs to do is take this HTTP request, take some data from it, and transform that data to some PHP structure and pass it to our core. And in our core, we have this create recipe service. It is a very simple service. Here I am passing just this string, primitive string value. Probably want to have something more robust, like a data transfer object or a value object or something like that. But I'm keeping it simple for the sake of this example. And what is important here is, now that we want to support another way of talking to our core, of creating a recipe via another way of talking to our application, we just implement another adapter. And here again, the only difference is that now we take input from a different source, but we still just pass data to our create recipe service that still lives in our core, and we didn't have to do any adjustments to the code that lives in our core, which is this create recipe service. We only added new code, this new concrete adapter. And again, our core really doesn't care if we are calling this service from a CLI command or HTTP controller, right? It is blissfully ignorant of the ways of talking to our application you are going to use. So this is on the driving side. Let's take a look at the driven side now, and it is going to be a bit more complex, but yeah, it's not that hard, but pay attention. So on the driven side, we have our create recipe. In the core, we have our create recipe service. This is our actual service, that kind of use case we have. So again, it's really simple. All it does is it takes this input, this string name of the recipe, it creates the recipe entity, and then it persists it by calling the save method on the dependency that it has, and that is the recipes repository. Now, if you were paying attention, you realize that we have a bit of a problem here. So we said that the dependencies are going inwards. So as we see in this image, the infrastructure can talk to the core, but the core cannot talk directly to infrastructure. Core should be unaware of concrete infrastructure you are using. And if you look at our code here, our create recipe use case, the create recipe service, it is dependent on the recipes repository. It is talking to it directly. It has it as a dependency. And the recipes repository, it lives in the infrastructure because it has some infrastructure related code to actually persist this entity, right? So this is problematic because we are now violating this rule of dependencies only going inwards. So what can we do about this? Well, we can use something that is called inversion of control, or people also call it the dependency inversion principle. And again, it sounds a bit scary, but what it actually means, as a rule of thumb, what you need to do is, when you have a situation like this, is to introduce an abstraction, usually an interface. So what we are going to do now is we are going to introduce this interface. So now the recipes repository, we're going to introduce an interface for it. And this interface is going to live in our core, because this is a concept that belongs to our domain, right? Saving recipes and fetching them. This is a concept that belongs to our core, to our domain. So now our create recipe service is dependent on this recipes interface, which lives in the core, and this is okay, right? Because they are both in the core, so we are not violating any dependencies here. And our concrete implementation of this interface, an SQL repository that will actually persist this, lives in the infrastructure. And it is also dependent on this interface, but that is also okay because infrastructure core code can talk to our core. It can be dependent on the core. So we are now not violating any of those dependencies going inwards rule. And this is why you see it's kind of like called dependency inversion, because now you see dependencies are kind of inversed, but yeah, that's a bit of another story. But yeah, this is how you can kind of use this trick to not violate these dependencies rules. And yeah, our SQL repository will now have some SQL specific code. Here we are using Doctrine ORM to actually persist this entity. So now that we know what hexagonal architecture is, how we show one way of implementing it. The question that remains is, why should we do it, right? What are the benefits of developing your applications this way? Well, the first big benefit is that it allows you to delay technical decisions. So why would this be important? Why would we want to delay technical decisions? Well, if you think about it, there is a certain paradox to how we develop software, how we work on our projects. And that is at the beginning of our project, where our project knowledge is at the minimum, because it's always going to, like with time, your project knowledge is only going to grow. So at the beginning, it's always at the minimum point. And at this minimum point, we are making big decisions on the technical decisions on what technology we are going to use. So wouldn't it be nice if we could delay these technical decisions to some point in time where our project knowledge will be at a bigger point, and then we can make a much more informed choice of technology we are going to use. And hexagonal architecture allows us to do just this. So for example, maybe you are not sure in your project, you are starting your new project, maybe you are not sure, do you want to use a SQL database or a NoSQL database? So what you can do is you can have those recipes, your repositories interfaces, you introduce interfaces for your repositories, and then you have these concrete implementations of these repositories, these interfaces, and you can implement them in plain PHP. It can be as simple as they just take your entity, they serialize it and save it to some text file. Now, this is not something you want to push to production, obviously, but it will work. It will work. You will be able to develop your domain, play around with it, model it, even write tests for it. And then when you have some more knowledge, when you're like more sure what technology you want to use, then maybe you say, okay, now I'm going to use a MySQL database. At that point, all you need to do is, only thing you need to do is implement new adapters. Now they're gonna really persist to MySQL database, and then you just plug those adapters instead of those naive PHP ones, and everything still works, right? Another thing about this is hexagonal architecture allows us to, even when we make these decisions, we can still kind of change our mind, right? So we can swap technologies relatively easily, right? So say we said, okay, we're going to use MySQL, and then for some reason later in the project, we say, oh, now we want to switch to Postgres, right? So again, only thing you need to do is write new adapters. And of course, writing new adapters can still be a lot of work, but you don't have to touch any existing code. Again, you don't have to touch any code in your core. You don't have to make any adjustments in your core, in your domain. Only thing you need to do is add new adapters, write some integration tests for them, and once you're sure that these adapters work, you just plug them in instead of those MySQL ones, and you're good to go. Everything still works as normal. And you can swap these technologies, like do this for every technology you are using. This is why it kind of like has this potential for timelessness, hexagonal architecture. Another thing why I like hexagonal architecture and why I think it's so popular in the domain-driven design community is that it really does allow you to really focus on the core when developing your application. So your core, your domain can really be domain-driven instead of kind of technology-driven. Now, of course, it is maybe a bit too idealistic to think that you can really model your core without any influence from the infrastructure, from the technologies you are going to use, but still it does allow you to really focus and not think about technologies you're going to use too much, which is, I guess, why it's really popular in the DDD community. And another big thing about hexagonal architecture, actually one of the big motivations for Alistair to kind of start thinking about it, is testability. So when it comes to testability, on the driving side, what you can do is you can replace your real adapters with test adapters. And test adapters in this context, this is your testing suite, right? And maybe you can have like this nice set of BDD style tests with Behead, where you can just plug them in and test your use cases, have your acceptance tests like this. So you can really test your application in isolation, and you don't have to go test your application by going through the UI. You can just plug in these tests instead of your UI and test your code directly. And when it comes to the driven side, to the secondary, to the infrastructure, again, you can replace your test infrastructure with some kind of, you can replace your real infrastructure with some kind of test infrastructure. So again, let's say maybe you are talking to some cloud provider or whatever. You can, again, create these adapters that will just be a kind of PHP implementation where you will just check if these calls are getting through. And this will help you because now you can really test your code in isolation, and your tests are going to be much faster because now you don't have to test every time you ping the real infrastructure. Now, don't get me wrong, you will still have your set of integration tests for your real adapters, but when you are testing your core, what you want to do is you want to test your business logic inside your core. You don't want to, every time you are testing a certain business case in your core, you don't really want it to ping the real infrastructure, because you don't need to retest this integration with real infrastructure every time you are testing every single business case in your domain. This is why you can have this, you can switch it with some testing infrastructure, so your tests are going to, when you're testing your core, your tests are going to run much faster, and then you have a separate set of integration tests to really test your adapters to make sure that this integration also really works. Okay, and finally, the final question to answer is, when should you actually use hexagonal architecture? Because some people, I mean, one thing that is true, hexagonal architecture, like every architecture, of course, adds some complexity to your code, right? And as I say, as every architecture, because every design pattern, they all add some complexity, right? And the question for me here is not that should we add this more complexity, but the question is, does it pay off, right? Because the reason why we have design patterns and higher, and even like higher languages, is because we as humans have a problem with grasping the complexity of a computer, right? A computer doesn't really care. You can write your application in binary, in machine code, right? People used to do that, but you cannot write it now like a real complex application. This is why we have these nice languages, and then we have these design patterns and all that stuff and architectures to help ourselves to grasp the complexity of our programs. So I would say that if your domain is complex enough and you think that you will gain the benefit of this little added complexity by using a certain architecture approach like hexagonal architecture, then I would say you should use it, and it will pay off. So the real question is, does it pay off? And that was it. Thank you for your attention. And if you have any questions, I believe we do have some time for questions.